Welcome in this session. In this session, we are going to state the second rule for chain rule for function of several variables. So the chain rule rule 2, the chain rules. So we are now in rule number 2, which is for functions of one independent variable and three intermediate variables. Function functions of one independent variable and three intermediate variables. So let's state the rule. So statement. So statements say that if W is a function depending on X, Y, Z is differentiable and X, Y, and Z are differentiable functions of time, then W is a differentiable function of T, and the W, the T is partial W partial X, dx dt plus partial W partial Y dy dt, and then plus partial W partial Z, and then dz dt. Or you can write it as, because the function is f, so say df dt equals to partial f partial x dx dt plus partial f partial y dy dt plus partial f partial z dz dt. So this is the second chain rule. So we'll call this one 2. So we can easily understand this from a branch diagram. So the branch diagram. So we have our function w, which depends on x, y, and z. So this is what you are calling the dependent variable. And then we have intermediate variables, 3 of them. So we have x, we have y, and we have z. And then we have the t here. So we can join this. You can join this. You can join this. And then you can join this. So that here is your x, here is your y, here is your z, here is your t. So these are intermediate variables. So the intermediate variables in this case are x, y, and z, and then independent variable. Now, so this is how we flow in this diagram. So this is how we flow. So here, this branch here, the change here is simply, it's only x depending on t. So this is the normal dx dt. On this branch, we also have just normal dy dt. And here we have dz dt. But on this branch here, this w is depending on 3 variables, x, y, and z. So therefore, this will be now partial derivative. So partial w, partial x, this will be partial w, partial y, this will be partial w, partial z. Or you can say partial f, partial x, partial f, partial y, partial f, partial z. So that now to get the dw dt, this branch will give you partial w, partial t. You multiply by up to the point you reach t. So dx dt plus this branch, you have partial w, partial y, and then you multiply by dy dt. And finally, this branch, partial w, partial z, dz dt. So this is a formula. Or if you don't want to use w, you can use f to write the same formula. You can say df dt equals to partial f, partial x, dx dt, plus partial f, partial y, dy dt, plus partial f, partial z, dz dt. So this is the chain rule for a case where you have 1 independent variable, 3 intermediate variables, and the function itself. So an example. given that W is x, y plus z, x equals to cos t, y equals to sin t, and z equals to t, find dw dt. Is that the problem? So the first thing is to write the formula solution. We'll have dw dt equals partial w partial x and then dx dt plus partial w partial y dy dt plus partial w partial z dz dt. Then partial w partial x from this one here, when we differentiate this function with respect to x partially, we get y dx dz dx dt. This with respect to dx with respect to time, we get minus sin t plus partial w partial y will give us x, and then dy dt will give us cos t. Partial w partial z will give us 1 because there's no z here, so 1. Dz dt will give us 1. So that is step 1. Step 2, replace y by its function, which is sine of t minus sine t, plus x is cosine of t times cosine of t. 1 by 1 is just 1. Then next step, when you simplify, you get this one as minus sine squared t plus cos squared t plus 1, which can be rearranged as cos squared t minus sine squared t plus 1. And as we have seen in the previous class, this cos squared t minus sine squared t is the same as cos of 2t plus 1. So this is the answer for dw dt. And then if you're asked to find, say, assuming that you're asked to solve this one at the point t equals to pi over 2, then the answer will be cosine of 2 times pi over 2 plus 1, which is cos of pi plus 1, and the answer will be 0. Cos negative 1 plus cosine of pi cos of pi is negative 1. Negative 1 plus 1, you get 0. And assuming you are to solve the change at t equals to 0, then this will be cos of 2 by 0 plus 1, which will be cos of 0 plus 1, which is 1 plus 1, and you get the answer to be 2. And if you are asked to find given that z is e raised to power x sine of y, x equals to s t squared, and then y equals to s squared t, find dz, find partial z, partial Z, partial S, and then domain 2, partial Z, partial T. So this problem will be solved in the next session once we understand how to apply the chain rule for a function depending on two independent variables and then two intermediate variables. So pause this one for the next class. When we meet there, we'll be able to solve this. So this one, pause. So let's meet in the next class. So thank you.